All right, I wanted to go ahead and actually take a look at the problems for the second practice exam. I'm going to do this one a little bit quicker than I did the first one, only because there's a lot of similar practice, and I just want to make sure that you have a solution set available sooner rather than later. So I want to get these videos up. It's actually Wednesday the 24th, 10 a.m. as I'm recording this, and I want to make sure that I can get these online before noon today. So an object has 30 joules of kinetic energy and a mass of 2 kilograms, and we want its speed. So I hope that right away you feel comfortable that the formula we want to use is EK is 1/2 mv squared. And we're simply going to throw in our numbers. So 30 is 1/2 times mass, which is 2, times v squared. V ends up being the square root of 30. And so when we solve, we're going to end up getting, grab my calculator here. Sorry. Going to end up getting about 5.5 meters per second. Now, it says, assuming the object in problem 1 was launched at the vertical speed, how high up does it go? Here's the interesting thing. Let's assume that no energy is dissipated. And one small thing I want to say is you don't actually need this number here. Since you have 30 joules at the beginning, if energy is conserved, which it is, assume it is, that mechanical energy is conserved, meaning there's none lost to, well, there's no dissipated energy. Energy is always conserved, but that we don't have any kinetic energy converted into dissipated, so we achieve less of a height. Instead, we have energy conserved such that EK equals EG. And so I can just say that 30 joules is going to equal mgh. And that means 30 equals 2 times 10 times h. And h ends up being 1.5 meters. So that works out really nicely. All right. Next, we have a spring that stores 80 joules and has a spring constant of 1,000 newtons per meter, and we want to get its compression. So this is clearly an elastic energy problem. So the elastic energy of the system is given by of just the spring, really. Let's not be dramatic. System. 1/2 kx squared. So we're going to have 80 equals 1/2 times 1,000 times x squared. And that's going to be 160 divided by 1,000. So that's 16 divided by 100 is x squared. So 0.16 equals x squared. So x ends up being 0.4 meters. It's a pretty big spring. It's like 40 centimeters. All right. Now, question 4. A 2 kilogram stone is dropped from a height of 20 meters and reaches the ground with a speed of 15 meters per second. And we have some energy dissipated due to air resistance when we read this whole thing. So what does that mean? We start off with all gravitational energy, and we're going to end up getting some kinetic and a little bit of dissipated energy right here. So let's set up our bar graph equation. So that's going to be Eg equals Ek plus E dissipated. And this is actually what we want to solve for. So we have mgh equals 1/2 mv squared plus this dissipated energy that we're solving for. So that'll be 2 times 10 times 20 equals 1/2 times 2 times 15 squared plus E dissipated. And so I'm going to end up getting 400 joules equals 15 squared. I believe that's 225. Let's see. Yep. Plus E dissipated. And so the dissipated energy ends up actually being 175 joules worth. So that's our dissipated energy. And that's the answer to number 4. That finishes up the first page of our second practice exam.